Hey everybody, this is Miss HK here, and today we are going to talk about dimensional analysis, which is a really long set of words to just say this is how to set up your math problems correctly. Because I don't know about you, but I have a really bad habit of multiplying when I was supposed to divide, or sometimes I end up dividing when I'm supposed to multiply. And so when I learned dimensional analysis, it was an absolute game changer for me. Dimensional analysis is just a way to help you set up your math problems, and it uses the units. So let's say you want to do something like you want to find out how many seconds old you are. Or let's not go all the way to seconds. Let's just figure out how many days old you are, okay? All right. So a lot of my students, not everybody, but a lot of my students are 15 years old, okay? And so you all know that 1 year is 365 days. Or we could write the exact same thing, just flip it as 365 days is the same thing as 1 year. These two things right here are called conversion factors. We are going to pick the conversion factor that has years on the bottom, because right now, here's what I know. All right, if you're 15 years old, there's my problem, 15 years. I'm going to put it over 1 just so you can see that 15 years is on top. I'm going to pick the conversion factor that has 365 days on the top and 1 year on the bottom. You guys have all had algebra class. You guys all know that if you have something on the top and the same thing on the bottom of an equation, it cancels out. So now I know that I set this up correctly because my years cancels out, and the absolute only thing that I have left is my days. So here is 15 years times 365 days, and I have 5,475 days. It is really, really easy if you're not using your units to accidentally do something like this, where you have 15 years, and it's really easy to unfortunately set things up like this, okay? And if you did your math that way, it would be 15 divided by 365, and that would say 0.04. Nope, not days. 0.04 years times years, so that's years squared, over days. Now, obviously right now you're all sitting here saying, nobody would be that dumb. I would never make that mistake. I'm the kind of person where I might not stop to think about it that deeply. If I was talking about how many days old I am, I'm definitely going to figure out that I am more than 0.4 days old. But if you're doing a math problem where you don't really know the stuff that well, you might not notice that this is a wrong answer, that this is a silly answer. So let's look at our unit. Our unit is years squared divided by days. That is a silly unit. That is not a reasonable thing. So that's the first thing that should clue you in, oh, I set this up wrong. And that would clue you up that you need to do it like this. So let me give you a real world example, okay? You guys have all heard of Disney World, Disneyland. There is a Disneyland in Tokyo, Japan. And they have a roller coaster called Space Mountain. There is a Space Mountain in Florida too. But the one in Tokyo derailed. The roller coaster came off of the track. And the reason it happened was because they didn't do their dimensional analysis correctly. The axle that connects the wheels is 1.25 inches in diameter. But they are in Japan, where everything is in the metric system. And so somebody needed to convert. They needed to go from inches to centimeters, okay? Well, here's the problem. Do we multiply by 2.54 centimeters? Or do we divide by 2.54 centimeters? Because that is going to give us wildly different answers. We have 1.25 times 2.54. So that is going to give us 3.175 centimeters. Or we have 1.25 divided by 2.54. Or this is going to be 0.49 centimeters. That's a huge difference. So how do we know which one is correct? Well, if you're doing dimensional analysis, you would have said 1 inch and just written that same 2.54 centimeters on the bottom. Remember, if something is on the bottom, you're dividing. All right, so that's exactly the same problem that I had before. I just wrote it out differently. Here's how you know whether it's right or wrong. On this one, inches on the top, inches on the bottom, inches cancels out. The only unit I have left is centimeters. That's what I want. Look at this one. I am so sorry for my really bad handwriting right now. We have inches times inches divided by centimeters. So our units over here is actually inches squared divided by centimeters. That weird unit is our indicator that this is wrong. This is not the thing that we should do. And we see this is what we should do. So if you have an axle that's 1.25 inches, you need to order one that is 3.75 centimeters. What really happened is that they ordered one that was 1.25 centimeters. So you can see that it was only about a third the diameter that it needed to be. And that's why the axle fell out and the roller coaster derailed. Your units are important. So in chemistry class, I'm going to ask you to please always write your units, especially when we're doing dimensional analysis. When you get into physics, units are everything, and I'm going to start teaching that to you now. So I'm going to stop here, and we're going to start practicing some dimensional analysis problems in class. Thank you.